Hi, in this video we're going to be continuing our discussion about polar coordinates by looking at tangent lines of graphs or functions given in polar coordinates. So we want to find dy dx in terms of r, theta, and maybe r prime of theta. So let's start by using what we know. So we know that x is equal to r cosine theta, and we know that y is equal to r sine theta. We also know that r is actually a function of theta. So let's go ahead and replace that. So x is equal to f of theta cosine of theta, and y is equal to f of theta sine of theta. Now this tells us that dx d theta is going to be equal to, using the product rule, the first times the derivative of the second, so f of theta times negative sine of theta, plus the first times the derivative of the second, plus the second times the derivative of the first, so f prime of theta cosine theta. And we also have dy dx is equal to the same thing, the first times the derivative of the second, plus the second times the derivative of the first. So that should be dy d theta. Now, we know from our discussion with parametric derivatives that dy dx is equal to dy d theta over dx d theta. So it's f of theta cosine theta plus f prime of theta sine of theta. And this is going to be divided by f of theta sine theta plus f prime of theta cosine theta. And that's negative f of theta. Okay, so now we're going to use the fact that r is equal to f of theta to tell us that f prime of theta is equal to dr d theta. So now we have that dy dx. Let's put our derivatives first. Dr d theta sine theta plus r cosine theta divided by dr d theta cosine theta minus r sine theta. So this is the formula for our derivative of a polar function. So for our example for this video, let's find the equation of the tangent line to r equals 3 plus 8 sine theta at theta equals pi over 6. Now remember that this is a plus b sine theta, where a is less than b, so this is a looped limicon. So we want to find dy dx, and that's r prime sine theta plus r cosine theta divided by r prime cosine theta minus r sine theta. So let's first start by finding r prime. So r prime is going to be equal to d theta of 3 plus 8 sine theta, which is just going to be 8 cosine of theta. So if we plug that in, we get dy dx is equal to 8 cosine theta sine of theta plus r cosine theta, so 3 plus 8 sine theta cosine theta, all divided by 8 cosine squared theta minus 3 plus 8 sine theta sine theta. And let's go ahead and actually resubstitute 3 plus 8 sine theta with r, because we already know what r is. So we can make this r cosine theta and r sine theta. So r is equal to 3 plus 8 sine theta, and we're looking at our theta equals pi over 6. So that tells us that r is going to be equal to 3 plus 8 times the sine of pi over 6, which is 1/2, so r is equal to 7. And while we're here, let's just go ahead and figure out what cosine of theta is. So cosine of pi over 6 is square root of 3 over 2, and sine of theta is 1/2. So plugging all of this in, we get dy dx is equal to 7 times cosine theta, square root of 3 over 2, times 1/2, plus 7 times cosine of theta, which is square root of 3 over 2, all divided by 8 cosine squared of theta, so 8 times 3/4, minus r sine theta, so minus 7 over 2. And when we finally evaluate this, we get dy dx is equal to 11 square root of 3 over 5. Now, while we've found what dy dx is, we still haven't found the equation of the tangent line. We've just found the slope of the tangent line. So we know that r is equal to 7 and theta is equal to pi over 6. And x is equal to r cosine theta, y is equal to r sine theta. So x is equal to r cosine of pi over 6, so that's 7 square root of 3 over 2, and this is 7/2. So we are at, 7 square root of 3 over 2, well, 7/2 is about 3, well, it is 3.5. And 7 square root of 3 over 2, it's about 14/2. So maybe it's about 7. So we go out to 7 on the x, we're about here, and 3.5 on the y, so 1, 2, 3 and a half. So we are right at this point on our graph, and we said that dy dx was 11 square root of 3 over 5, and 11 square root of 3 over 5 is about 2 square roots of 3, which is, give or take, 2 times 1.7, so that's about 3.5 as well. And if we were to draw the tangent line here, we would see that our slope is about 3. So the equation of the tangent line is going to be y minus 7/2 is equal to our slope, which is 11 square root of 3 over 5, x minus 7 square root of 3 over 2. And that is good enough for us. It is the proper equation. It is a proper equation. It's not in y equals mx plus b form, but point slope form, is just as good as any other form, if not better. If you have any questions, comments, or concerns, leave them in the comments below, and as always, thank you for watching.